Welcome everyone to this Tuesday's edition of EET 2303 on the 7th of April. And this continue again with a brief discussion about the assignment we're working on, forest growth. And we're going to look at the third equation or the third case that we will need for this particular program. Again, it's a continuation of what we've been doing before. And so what is today's problem that we're going to address? Well, we want to write a program that solves for the timber regrowth issues, and this time specifically we are asking the question, I've got a forest and I want to cut some trees down today, but the government has some certain regulations or issues or whatever, and they want to make sure I don't cut down too many trees. And so the Forest Service says, oh yeah, you can cut some trees down from your forest today, but this is the issue. We don't want you to cut down too many trees, and so this is the limit we're going to put on you. We want to make sure that in 10 years' time the forest is still growing and prospering, and so it needs to be, say, 125% of the size that it is today. And so the first question you might ask was, is that even possible? Can I cut down any trees and the forest will be bigger in 10 years? Well, it depends on your growth rate. If you have an old slow growth forest, it might not be possible, but if you've got a pine forest or some other kind of fast growing tree, maybe it is possible to cut some trees and have a forest that is bigger. So for example, let's say you have a forest that's 100 acres in size, a purely arbitrary number, and the government man says cut down some trees, but the forest in 10 years must be 125 acres in size. So your assignment, write a program for the boss to see if it's possible, and you will need the following parameters. Well, obviously you're going to need the growth rate, so you've already got a function that gets the growth rate hopefully by now. You need a function that will get how many years you have to grow the forest back, whether it's 10 or some other value, it doesn't really matter. Obviously you need to know how big your forest is, and you also need to know what the future size of the forest will be or is required to be. And then you need to run a calculation. How many trees can you cut down? Well, fortunately there is a nice interest rate calculation that will work for us, and it's this one right here. The number of trees you can cut, C, is equal to the number of trees that you will need in the future divided by 1 plus I raised to the nth power. Just a very simple exponential function that again, if you wrote that one the other day for the case part 2, this shouldn't be too difficult to do. Okay, that is the first step. This is the first step. Now, once you have this number or this value C calculated, you need to take that and ask, okay, C needs to fit a certain parameter. It must be less than your current size of your forest. So let's say you run the calculations and you want a forest to be 125 acres, and your calculation says your forest needs to be 105 acres in size, but you only have a 100-acre forest. So what that says is, oh, I can't cut any trees. As a matter of fact, I'm 5 acres short to being able to even meet the goal to begin with. Or it may be that, oh, C comes out to be 60 acres and I have 100 acres. So that means, oh, I've got to leave 60 acres, so that means I can cut how many trees down? 40. So I guess, that's another step we should ask is, how many can we cut down? I should have wrote that in there. In other words, this value C is how many trees I have to leave standing to reach the future value goal. Well, how many trees I have left standing obviously have to be bigger, or has to be less than my forest size I have today. So if C is not less than PV, it's not even possible. If C is less than PV, then I can subtract that number from PV, and the result of that number will tell me, how many trees can we cut down. Obviously, your program should validate each entry, and incorrect entries or improbable entries should be re-entered. And you must use, a separate function to solve each one of these problems. And all other aspects of the program are up to your discretion. So really, you're only adding a couple more functions to what you already have. And as always, the program should continue to run until the operator says quit, which should already be something built into your program. So the quiz for today, what is the equation to find the value C? Just reply back to me with that equation, and you will get attendance points for today. Again, everybody stay well, and hopefully this program is going well for you.